All right, so let's take a look at an example. And so in this case, we want to find the lowest energy conformer of this molecule. And we're going to go ahead and look down this bond right here. And so we're going to start off by drawing our front carbon. And this is probably the most difficult part, going from the skeletal structure to the actual first Newman projection. After that, rotating it isn't as bad. But first thing we see is a methyl that's pointing straight down. And then we see a wedge methyl, right? Wedge, if you think about you rotating this so you can look down this bond, this wedge is going to point to the top right now, which means that we'll have a hydrogen off to the top left. And then over here in this back carbon, what we notice is that we have an ethyl group that's pointing straight up, right? It's pointing straight up from our point of view. So we want to copy that down into the Newman projection, so ET there. And then over here, we notice that we have another methyl group. It's going to point to the bottom right this time, leaving a hydrogen from that dash there. And if this is difficult for you to see, you may want to think about purchasing a model kit. A model kit will be able to allow you to see this molecule really well. And so then we just want to pick one carbon to rotate. I generally do the one in the back. So let's go ahead and pick this ethane and then rotate it about. So we'll just go ahead and keep everything in orange exactly the same. Right, we're just going to move one of our carbons. And now this ethyl will go back to the bottom right. This methyl will be shifted over. And then a hydrogen will end up on top. And then we do this one more time. Now our ethyl is on the bottom left. The CH3 would rotate up top, and then the hydrogen would be down on the bottom right. And so we can go ahead and take a look at our three conformers. Again, if we tried to rotate this some more, we would be back at our first conformer, right? So we've drawn all the possible options. Now let's think about what kind of interactions we have and find the lowest one, right? So we have a Gauss interaction between this ethyl and this methyl Gauss interaction, and then a methyl Gauss interaction. So there's essentially 3 Gauss interactions right here. And then this one we have 3 as well, right? 2 ethyl methyl and 1 methyl Gauss interaction. And then over here on this one, we only have 2. So we can tell one of them has significantly less Gauss interactions than the other. And so that one will be our lowest energy conformers, right? And so this will be lowest energy. And then how do we determine between the first two, right? They both have 3 Gauss interactions. Which one's going to be the next lowest if we were asked that question? Well, think about the type of Gauss interactions. The biggest thing here we have is our ethyl group. So we want that one to have the least amount of Gauss interactions because it's the biggest thing. And so here it has 1 Gauss interaction, but here this ethyl group has 2 Gauss interactions, right? And so the one with only Gauss interactions will be better, or with only 1 Gauss interaction, 1 Gauss ethyl methyl interaction will be better than the one with 2. So this will then be the kind of the second lowest. And then this one will be the highest energy of these 3. Of course, that's not the highest energy because that would be the eclipsed version. One big thing when drawing these Newman projection is to always follow your molecule. And so when you're drawing the initial Newman projection, make sure that you're drawing it from the molecule that's pictured and that you're not just randomly placing things however you want, right? So let's take a look at an example of that. So here we have the molecule that we just drew. And then here we have another molecule. And overall, they look very, very similar, right? They both got this pentane motif. And then they're both 2,3 dimethyls, right? So are they the same or are they different? Let's go ahead and check that out. So for both of them, we're going to draw our Newman projection looking down this bond. Draw our front carbons, and these two are the same, right? They're both wedges with the methyl, so that top right in the methyl, carbon pointing straight down, and then hydrogen to the top left. and then draw our back carbon here. So in this back carbon, we've got an ethyl pointing to the top, and then a methyl to the bottom right, and then a hydrogen from that dash. Let's check out this other one. And again, here we have an ethyl pointing right up top, but this time our methyl is on the bottom left and the hydrogen is now the wedge. And so we can see that in this case, our orange parts of the molecule are the same, so we don't want to move that around. And then we see that we have this ethyl on top of here, but then our methyls are in different spots, right? And no matter how you try to rotate it, go ahead and try to rotate it to make these two molecules match or be superimposable, and there's no way to do it, right? These are actually going to be different molecules. And we'll focus on this later on. The main point of the story here is that you want to draw your initial Newman projection by drawing what you actually see. And be careful of these molecules, because even if they look the same, they might look a little bit different. So again, follow your Newman projection. And then let's go ahead and go back to the first molecule that we saw and draw the highest energy conformer. And so again, we can just go ahead and draw this first carbon just the way it is, and then just move only the back carbon. And then in the, whoops, my bad, forgot this ethyl group here. And then in the back carbon, right, if we're trying to maximize the interactions, what we want is the maximum eclipsing, right? So if we moved this ethyl over here to eclipse with this carbon, then this other methyl would be eclipsed, and then we'd have two hydrogens over here. And so that would be the highest energy, right, where we have maximum eclipsing. Right, we've got two eclipsing interactions with two methyls and then a methyl and an ethyl. There's another conformer you could draw where you only have one eclipsing interaction, right? That's not going to be as high of energy. So just get some practice in, it shouldn't be too bad.